Good afternoon. This is Andy Schweitzer, and a little topic of work. What is work? What is energy? When is work being done? When is work not being done? So, in physics, work is a slightly different definition than, let's say, a high school student that's going to work at McDonald's. Okay, Golden Arch of McDonald's, Mickey D's. That to them is doing work. Um, but in physics and science, work has a definite definition. Basically, work is to cause movement, means to do work. Um, in this case, more terms of physics, you would apply a force to an item and you would cause it to move over the course of a distance. Okay? So a force over a distance, you have achieved work. You simply have to move something. Work could be done on the microscopic level of moving atoms, or it could be done on the big level of moving cars, or even bigger as far as plants. But either way, you have an item and a force is applied to this and this item, and then it moves this item over the course of a distance, and this distance right here, and of course at that point work has been achieved. I could, if I were to hit this particular item, and let's say this particular item does not move, I could be pushing on it until I'm blue in the face. But if it does not move, then I have done no work. I could take this same box and I could lift it up into the air, and I could, Mr. Stickman could simply have the box right here, and I have done work. I have moved the box from the height of the ground at, let's say, point 0 up to this point right here, and I have achieved movement of the box. Therefore, I've done work to lift the box. Now, even though I have this box here, and the box can be getting quite heavy, and you could be sweating over the fact that this particular box is starting to get heavy, and no more work has been done after the box is lifted to this height. At this point, right now, how much work is Mr. Stickman doing? Mr. Stickman's not doing any work right now. And I'm not saying he's not expending energy, but he's not expending doing any work. Work is a force is applied through a distance that causes movement. Okay? You can apply a force down on this particular item. That little drive's kicking in and out. Sorry about that. If I apply a force and it's not in the direction of the movement, then of course no movement will occur due to that force, and therefore no work is done due to that force. So I could apply a force down, okay? Gravity, of course, is pulling the box down, but it's not causing any movement of the box. This particular force causes the box to move to the side, therefore this force does work, this force does not. Just for example, I could take this box and I could pick it up and put it on top of a table. The fact that you put the box up there, that is a certain amount of work. You've moved it a certain distance. But the table's not doing any work. The table's simply holding it there. Okay? So what is work? It's causing an item to move. All right? You're applying a force over a distance, and that force applied over moving an object over a distance is doing equals work. Very unique item. Now, force would be in unit of newtons. A distance is a unit of meters. Okay, so you put those two things together, and you get a Newton meter. Another name for a Newton meter is a joule. All right, so what is work? It's mentioned a few times already. Energy, this essentially is energy. Is our main unit of energy is a joule. So, although energy can be represented in many different ways, it very easily can be measured through work. And as work's being done, energy is being transferred. So, I can take energy from one item and apply it through a force into another item, and that could be therefore responded into work. When is work being done and when is it not being done? Well, it's done when movement is occurring, and the force has to be applied in the direction of movement. It could be you can do work slowing movement, starting moving, or stopping movement, but it wouldn't be in a different direction to the actual movement. Okay. If a if a car is traveling down a road, and let's say it's traveling this way, and very often you'll see some of the older movies, you'll see Superman come down, and the car's moving, and Superman lands, and Superman stands here and puts his car hand out there and stops the car. It's moving, and he stops the movement. Superman is doing work by stopping movement. That also would be a good example of work. He is applying energy, stopping the car, or he could very well push the car back in direction and do more work. So work involves either creating movement or stopping movement, causing or stopping movement. And that's really all work is. When is work being done and when is it not being done? Okay, so now we'll just kind of wrap up here with units. And we'll do two more things here. One is going to be units. Again, just so you know, a unit of a Newton is the force. A meter, therefore we get a joule. A Newton is a kilogram meter per second squared. That's from mass times acceleration equals a force. So that's kilograms times acceleration, which is meters per second. Multiply that again times meter, and we get a kilogram meter squared per second. I should say, well, I'll use seconds squared. Kilograms meters per second, meters squared per second squared. And this is the same thing as a joule. Now, the very last thing we'll mention here is what is power. Okay, power is the amount of energy per time. So in this case, that's one more added little twist to it. You're traveling have a certain amount of force over a certain distance per time. So this is power, which is very unique and has lots of applications to all sorts of areas of science. A lot of times we will have light bulbs rated in power. That's energy per time. You could give a lot of energy, do a lot of work in a very short period of time, or you can spread it out over time. So that's the last concept here, just units and what is work, energy, and very little bit on power. Thank you very much.